Hi, welcome to another video podcast. We're going to be looking at how to draw the ray diagram for an optical telescope, for an astronomical telescope. I'm just going to give a little bit of background to start with on ray diagrams in general for lenses and the sort of principles for how that works. All ray diagrams rely on an optical axis to get everything lined up, and the lens is just represented by a line. The key thing to know about for a lens is the location of the principal focus, okay, which is equidistant either side of the lens. And then by definition, any ray that arrives at the lens travelling parallel to the optical axis will then be steered through the principal focus. Any ray that arrives at the lens having come from the principal focus will then be bent parallel to the optical axis. And using those two facts, actually I'll give you one more. Any ray travelling through the centre of the lens will carry on in a straight line. And those are the principles we're going to use to put together our ray diagram of the optical telescope. Again, starting off by drawing our optical axis. We're now going to have to accommodate two lenses, both with their own principal foci. Make the focal length of the objective lens, that's the one closest to the star you're looking at, longer. I'm going to go for 5 centimeters there. And then we'll make the the focal length of the eyepiece lens just 2 centimeters. We don't want to go for too much magnification, otherwise it will get very hard to draw. The principal focus here, this is the principal focus both of the eyepiece lens and the objective lens. So I'll just draw some in. Now, it may be the case that some of these rays don't actually appear to pass directly through the eyepiece. And to a certain extent, we have to not worry about that too much there. So a lot of what we're drawing is merely for construction, to show in principle how the telescope works. We draw 3 rays that are coming into our telescope from an imaginary star. And the easiest ray, obviously, to draw is the one that travels through the objective lens in the centre, because that simply carries on through as a straight line. And you don't want to make this angle here too big. Draw another ray about equidistant on the other side, and it will be easier, I think, to do this next part if we make sure that that has come from the principal focus, goes through the principal focus, because that's now the ray we know it's going to do. The rays that come from go through the principal focus have to be bent and turned so that it goes parallel to the optical axis here, and it should cross that ray in line with the principal focus, because rays from infinity should cross at the principal focus. So we can draw in that ray there. We then go for another ray about equidistance up here. How do we know where that ray goes? Well, all we can do is we'll say that this should have been lined up just slightly better with the principal focus. Okay, so that really should cross there in line with those 2 principal foci. And now, where are these rays going to go from here? Well, if you're lucky enough, as I am, to have a ray that's travelled parallel to the optical axis, then you can simply say, well, that one will now emerge out through that principal focus, and the other rays will emerge parallel to that. There are some circumstances where we might not have a ray going parallel to the optical axis, so how do we know what to do? Well, we'd create what's called a construction ray, a ray arriving from this point would, if it was there, travel straight through the centre of the lens, and these rays emerge parallel. And the magnification is the increase of that angle compared to that angle. It's quite modest in this diagram because I've tried to keep the magnification small, otherwise it becomes difficult to draw the diagram. Obviously, I don't think you need to be able to draw this for the exam, but the human eye would go here, and we've concentrated the light through the pupil and increased the angular separation between two objects. Hope you found that helpful. Thank you.